Ooh. Are we live? Are we? Are we? Seems like we are. Alright. Where's my audio? Hey! Hello everyone! Let me change the topic. Man, I was so busy. Sparks. Just like that. Sparks. Sparks. Here we go. Man. So busy today. How are you guys? How are you? Just put my chat here. Workflow in mind. Yay. How are you? I'm good. I'm great. How are you, Trevor? Been really busy today. I almost forgot about the webinar. I was like, well, I should be making a webinar right now. Woo. Totally wasn't aware of that. And I'm actually alrighty. So how are you guys? How's everyone? Christian, having a beer? Oh, that sounds good, man. For you. I don't drink beer, but sounds good. Having a beer, it's you're relaxed, you're doing good. Whew, alright. Who else is here? Bronick. Hey Bronick. Sean. Kristen. Trevor. I already said Trevor. Chance Norris. Hey, what's up, man? I'm good. I'm doing good. I'm doing good. I'm doing good. So we're gonna talk about Sparks today, which is something that everyone should know about. It seems like nobody talks enough about Sparks, and they are so important. Really important. So let's just wait a few minutes so people can get here, and we will start in a few minutes. Yeah, LearnDay is a very nice day because we can learn stuff. Cool. Hey, how are you? The Patrick, maybe? I don't know. If you told me your name before, please write your name again. Tell me. Chance Norris, I haven't tried sync. I want to, but I haven't. I have it in my to-do list, I guess. Sin, hey there. Not sunny in Albuquerque, eh, Trevor? Why? Albuquerque, it's regularly sunny. It's kind of cloudy today here, and it was surprisingly cold today. I don't know why. Temperature just went down for some odd reason. Just have been doing so much stuff that I have so much stuff on my mind. I have to get clear of that and start with this particle stingy. Sparky. Let me open this Sparks file. I think this is gonna fail. Are you gonna fail? I think it did fail. My menu has a bug. I need to fix that bug. My menu has a bug. So there we go. Now we have particles. Or they're calculated. Yeah. Particles. Yay. Yay, particles. Alright. Let me close some stuff because I don't want to be distracted. with all this stuff. So, who else here? Peter. Hey, Peter. Peter from Northern Ireland. Ireland. That's great. I am in north of Mexico, in the border with the US. I can be within a few minutes of El Paso here. Whitewater bubbles tutorial. I haven't seen any in a while. Okay, alright, so there's been a few minutes, so let's start with Sparks. And what's wrong, boy? Alright, should be looking at that right now. Okay. So Sparkies. I think this is gonna be a long one because Sparks are not simple. There are complex stuff to do, but the basics are simple. We've done particles before, right? Did we have particles webinar already? Let me check. I think we did. Hey Jason, sup? 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 Particles. I'm not sure. Yeah, totally drawing a blank today. Particles. I think we did. Yeah, we did have a particles basics already, and particles following a curve, and disintegrating geometry with particles. So yeah, there's been a few of them particles. That's good. Shit. Peter, you can try to follow along, but I might be doing stuff a little bit quick if you want to follow along, but the video will be available once we're done, so if you want to try something up, you can just try it after that. So I'm just gonna show you this simple thing that I did yesterday, which, let me just close a few things here. Just made these quick particles yesterday. There you go. That's some particles, some sparks with a lot of depth of field. Let me open this in another player because that one closes auto magically. This one's better. So I just made some particles in Houdini. I make them emit. Made a really emissive material. Made a camera with a lot of depth of field. And then I added a few elements in Fusion just to add a little bit of glow. Just simple glow, and didn't do much. You could see actually I have the render here. So this is the raw render. You can see I rendered the depth of field with the particles just because I just wanted to do it just for fun, rendering the depth of field, which is cool. And we're gonna see how the elements, which elements we need for this, because we kind of need this to be kind of lines, not just points. So let's see what we can do, right? So you can see this is the scene that I have, just particles bursting there from a sphere. And the setup's pretty simple. This is basically setup, initial setup. And the DOPNet, you can see this looks pretty simple. Just had the Bob network, the fireworks example there for reference. But it's gonna be really simple actually. So I guess I'm gonna keep this around just so I don't make any huge mistakes and just lose time. So I'm gonna put this inside here. Let me open a new one. Alright, so we are gonna use particles to do the sparks, right? And if you are thinking, why the hell sparks? Well, sparks are really essential to a lot of effects. So you need to do sparks. Sparks are really important. They are almost in every effect. There's particles and sparks, or some if it's not fire, you will see a lot of particles, kind of like sparks, but with when you're destroying like destructions of concrete and stuff, you do a lot of really small particles to give it more depth to the effect. So it's pretty cool to learn this trick. So let's start with a sphere. Or no, let's start with Roberto. Why not? Roberto can be the source of the particles. Let's put it a little bit higher there, and let's just emit particles from this. I don't want the shader on Roberto, and I'm just gonna create a pop network here. Directly plug that in, go inside, and you can see we magically have particles. Not sure what the source. Oh yeah, I know why. Let me move this inside here. Transform, move it up a little bit. There. So the particles are there. I'm gonna make the points bigger just so you guys can see them. Let me see the point sizes here. There we go. It seems like Roberto is sick. He's not. Can you map sparks to real-time data from the web? I don't know how. I don't know what you're talking about. I don't know what you're talking about. So, alright, so we have these particles and Roberto is getting sick, you know? It's really sick today. So, and if you go back, get sicker and sicker. Alright, so we have those particles from Roberto. We need velocity to actually make it go from Roberto to the outside. So that's pretty simple. We can use the normals. Right now we have those normals, but they're just, I don't know. Yeah, it does have normals. Roberto comes with packed normals, so we can use those normals, but I want the normals to go up and just make them up, and we are gonna bring the particles down with gravity. So let's use the points up, change this to normal, change this to constant value, and put this to 1. So there we go. We're going up. Maybe 0.2 on the size. Oh, no, it's not. It's not going to the center. All right, like that. Sure, I like that. We can also randomize the normals with an attribute randomize a little bit, maybe. Let's randomize the n, and that's to between two values, -1 and 1. Like that, but they're not randomized. Not that randomized. Let's change this to distribution Gaussian. There we go. They are kind of randomized, but not too much. I don't want them to be that much. There. Those normals now, just gonna make them go to the make them go with the wrangle. Just put the normals in the velocity. Just gonna make the velocity equals the normal. That's pretty simple stuff. If you don't know how, that was an email I sent a few minutes ago. It's just like that. That's the specs I'm writing. Attribute velocity is gonna be equal to the attribute normal. Done. Alrighty, specs. There you go. Alright, so there we go. That's gonna give us the velocities, and I'm gonna have to hold them for 1 second. I'm gonna come back. Talk between yourselves. Talk among yourselves. Alright, I'm back. My wife left and left me with a cake in the oven. Literally, a cake in the oven. The cake is done. We can all eat cake after the fact. Alright, so now we have those normals. Let's just do that. We have the velocity. Now the particles are going in the direction of the that we set, right? So that's how we can control the direction that we want for the particles. Alright? Could be better. It's not going to the, it's not randomizing in the Z direction for some reason. Let's go see what we're doing here. See what's happening. And I screwed up everything, right? I'm doing it in 2 dimensions. For some reason, I didn't set this to 3 dimensions, and now it looks weird. Yeah, it does look weird. That looks better, but it's not going in XC for some reason. Alright, we're gonna go for this for the moment, so we don't lose time with that. Cool. Alright. I'm gonna add some noise to this, so it's gonna be good. So let's see if so we're not talking about attracting thingies right now, but you can kill the particle once it's there's an option for sticking the particles. Okay. Yes, Nathan, all the videos are uploaded. Once we're done, they'll be available for watching later. Alright, so we have these particles. Let's go inside. We have Roberto here. And we don't want to emit those as much particles, so let's just put this to, let's say, if I kind of like that's good. Alright, so now I'm gonna use some gravity here at the very end. Don't disconnect that. So let's just put some gravity here, and also put a merge and ground plane. So we are gonna make the particles collide, make the ground plane the first one. So now the particles fall and they collide with the ground, but now they are not fast enough. So let's go here to the attributes and make the inherent velocity more or add to it, and now we can have that, which is cool. They are going up and bouncing. Let me put this to real time. Put this higher. Yeah, I like that. They are jumping. Let's add more variance in C since we didn't have it before. That's good. And let's put some more variance in X. There we go. I like that. That's good. That's good enough. Subsido, I didn't ignore your question, but it's not on topic. We are talking about particle sparks right now, and we can be talking about pyro trails, so that's why. I'm sorry, but I need to stay on topic here. Hello, Karen. Karen from Romania. Hey, man. How are you? Alright, so the particles are huge now, so I'm gonna go to the burst tab and make the life expectancy really low, like let's say 1 second, and variance of half a second. And some will bounce, some will not. I'm gonna make this ground plane black. I don't want it to be that. Right, that looks good. Or I can just hide it, but I like it. I like to see it sometimes. So there we go. There's the particles. The first step of our sparks are there. So we're gonna do this. Is basically some particles could be like this, some sparks. So let's make the whole process of rendering these guys to make them look like sparks. So let's create a camera, and let's do that camera. I'm not gonna use a light, I'm just gonna use a camera. And then I'm gonna create entropy VR to render this. Now if we go and render this, let me override the camera size. This is not gonna look pleasing. So first let's go here. So scene view, we have both objects, the floor and the particles. Let's just select which object we want. We rename this to particles, and said that we don't want every object, we just need the particles object. And I think I miss no, there it is. We just have the particles now here. So if we go and render this, it's gonna be huge. First, particles are big. Well, unless they're not that big, but they are big. We can just control that with the geometry point scale here, 0.2 maybe. You can see the particles are there, pretty small now. 0.3. Let's do 0.4 for now, so you guys can see them because they are small. The other thing is these particles don't look nothing like sparks. They are just points, dots. They don't look like sparks. So for that, we're gonna do two elements. The first element is gonna be the velocity of the particles. This is one of the ways you can do it. We have to render motion blur. And now if we render with motion blur, this guy's gonna look better once we go here to the object and activate the geometry velocity blur. Now you can see they're starting to look like streaks. And what I sometimes do is just put another wrangle here, and the current velocity, I just multiply it by some number, like let's say 5. You can see now I have longer streaks there. And let's put it to 2 maybe. It's too long, 3. And let me show you what I'm doing. So this is what I'm typing here. The velocity, the attribute velocity, which already exists here. You can see it comes from here. The velocity from the particle should be here. we are just multiplying that, whatever value is there, multiply it by 3. That's what that is. It's very simple Vex expression, and that's how you can make longer streaks. You can make something crazy there and it's gonna be way longer, which I've done sometimes for stuff, but that's how you can make those longer streaks there. Maybe I went too small with this, make it bigger, and you can see the streaks are now starting to look more like particles. And let's see if there's any questions. Do I have a schedule for live streaming? Every Wednesday, yeah, every Wednesday at 4 p.m. GMT -7, this same time, we are gonna be live. Hopefully forever, because I'm a vampire. I can just stream till the end of the world. Maybe even after that, I don't know. If there's an internet after that, I could, because I'm gonna live. Just kidding. Alright, so these things are starting to look like streaks, like particles, and I actually forgot to show you guys the some footage, which is this. I'm gonna give you the link of this. It's a really nice video reference for sparks. You can see there's some sparks there. There's some very sudden sparks. Some of these sparks kind of split when they die. These are like fire sparks. There's a bunch of sparks here. You can see there's another sparky effect there. Some more sparks at the camera, sparks colliding, some more sparks. This is kind of what we're going for right now, like this kind of sparks right here. So this is kind of what we're going for right now. We are going to do a few styles, but this is the first one. You can see we have that shape already. And it might be too big, so let's make them not too long. Let's make it 2. 2 it's gonna work, I guess, I think. But the other thing is they have different scales. You can see some are small, some are wider, and we're gonna do that next. But the other thing is that they have to kind of glow, right? They are emissive. They have light. So let's create a principal shader for that. The principal shader is gonna be our shader for this, and we're gonna call this particles 1. And for this, just put the color to white. We're not gonna use this color, and we have an emissive color here. Let's put this to, these guys were kind of blue, right? So let's make it blue, like a little bit of blue, a little bit of purple there. So let's go pull it sometime to kind of there, and let's assign this thing to the particles here. Assign it particles. Now we render this. It was rendering. I stopped it. They're gonna look purple. Yay! But we don't want it to be purple. So what we need to do is let's save a snapshot of that. Go to the emission intensity here and crank it up like something crazy, like 10. And now you can see this is starting to look cool, but we need more, maybe 50. And this is starting to look like a pink, so we need to change the color to something more blue, or something more like we don't want it to be pink. We want it to be a little bit blue, but mostly white at the very core. So something like that. You can see some of them are really white with the core, and but they have a little bit of color. So that would be good. Let's make them a little bit more to the blue side. Or even if they are like this, they are gonna look cool also if you make them red, even darker. But they're gonna go for blue for now. Those blue ones look cool. We don't want too much blue, but we want them to be having a little bit of color. There we go. That looks cool. That's nice. Now the shaders started to look, they are starting to look with both elements, the motion blur and the shader with the large, very big intensity. Now it's starting to look like sparks, right? Cool. So those two elements. Let me save this. Sparks live. There we go. So those two elements make the sparks look like sparks. Let me make more subsamples here, and they look cool. Righty. And make the camera bigger. Yeah, that looks cool. That looks like those sparks we were looking at there. Starting to look like those guys. Pretty cool. Let me do that. Save this to see if there's any questions. Yeah, the Mantra surface shader now is renamed the classic shader, and if you want to use that you can, but I recommend you use the principal shader. It's much faster. It's much faster than the classic shader. Alright, so this is one kind of particle, right? We can save this, and this could be just one effect of particles, you know. This is good. Oh, we need to change the size of this. So we have this. Let me just multiply velocity. Call this normals and to b. Let's call this, because the normal is going to the velocity. And I don't rename this as much as I should. And initial direction and randomize n. Alright, cool. We need to make some particles smaller and some bigger. There is a really nice attribute from particles, which is the ID attribute, which is unique for each particle. You can see, let's go here. Here you can see it. Each particle has an ID attribute, and this is not the same as the point number, because the particles, you can see, even if they die, you can see, let me hide everything, just show the ID. You can see this is the point number 0, but the ID stays the same as when the particle was born. So this particle was that number of particles. Before this particle, there were 1,375 particles before it. So the ID never changed for the particles. They have their unique ID all the time, and we can use that for this stuff like change the very different things for the particles, like the velocity, the scale in this case. So let's just do a pop drag here, just because I'm feeling kind of like I need the pop drag, but it's gonna start. Don't make it so resistant, kind of like that. All right, or just didn't want it to just not have any drag there, because we should always have drag. There we go. I like that. I like that. A little bit of drag, it's always good. You should never just have your particles doing whatever they want. Control them. Alright, let me reduce the pixel samples. Alright, so the scale of the particles are going to be varied by the ID number, which we talked about. So let's just I always use a wrangle, but I'm trying to use more this randomized attribute or node, actually, sorry. But default it randomizes the color. You can see it's just adding color to these things. But I want to randomize an attribute that doesn't exist. I don't know if this works. Let's see, p scale doesn't exist, so it does create it. Cool. Let's see, p scale doesn't exist here. Nope. Ah, cool. So it does create the attribute doesn't exist. Cool. hide everything, just show the P scale, and we can vary. This is just one dimension, just one value, and we can just say give me some different values between these values here. So we can say the minimum value. We can maybe do this while we render this. Let's say if we render this, some particle is gonna be huge like that because the max value is 1. Let's make it smaller. Now you can see we have small particles and bigger particles. We can make this even smaller. The max value, let's say a little bit smaller, and the minimum value not so small. Let's make it a little bit higher. Cool, but now we have a difference in particles. Not so, let me make this smaller. And yeah, that looks cool. Now we have particles that are smaller and some that are bigger, and they look better, more natural, instead of just everyone being the same color. I mean the same width. Okay. Can we make particle color emit from geometry point color? Oh, you mean like, yeah, I know what you mean. Yeah, you can totally do that. You need to have color on the geometry. Let's add the color for Roberto here. I should have its color here. Let me just find it. Textures. I should have Roberto's colors here. There we go. So yeah, if you have these colors on the geometry, this is not a texture. This is not a texture. This is actual color in the points. So you need to have that color in the points. If you have that color, just by having the color, when you go to the PopNet, the particles will inherit the color of the surface, like that. You can see they are doing it right now. I just need to have the color, and they will take that color. That's easily done, and we can actually render this. Let's see how it looks with the Roberto colors, which are blue. Let's see how it looks. There you go. We're using the colors of Roberto, but it's just really intense. But yeah, that's how you just pass the colors from the surface to the particles. Can I suggest that what you type should show on the screen? I've been trying to use this tool for showing that, but I don't really like it. But I'm gonna try again to put this freaking tool. I don't really like it, but here it is. You can look here and you can see I can press Ctrl S, or I can press U for up, and there you go. So you can see that, and that's what I'm pressing. All right. Hey Francisco, what's up, man? So that's how you make the basic particles, I mean the basic sparks effect, alright? We have these particles emitting from geometry. We needed to add motion blur to them, and we needed to add an emissive material, and we needed to add the scale, for the P scale, to make them bigger. Now if you have really small particles like this one, you can see there's more samples you need for this. So for that, this is not actually the production samples. Most of the time I just render up to 6, and that will give you good samples there, good enough samples to sample your geometry. If I change this to the final size, you can see there, that's the size. And if you need more samples than this, well, you can just give it a little more samples. I regularly never go above 9 here, so just make be conscious that this is gonna go fast. So if you have a little bit of noise, it's not gonna be noticeable. So there you go. That's how you make those look cool at the end of the show, right? All right, so we need to, now let's make this, take this effect and make it better. Let's make another one of this. Just copy the same setup and let's do here, call it splits. And why did I put a no there, a 0 there? So let's go here, and we have all the setup that we need here. So now we're gonna kill the particles when they collide. So let's make the particles live a little bit longer. So let's say what we're gonna do. So that's always good for me. I can just say I'm gonna do this, and then I just follow that, whatever I'm trying to figure out in my mind here. So we want the particles to emit, collide with the ground, and when they collide, they're gonna spark and they're gonna die. All right, that's what's gonna happen. And the question is, can I render pops with redshift? Yes, you can. Without instance, no, you can't do it without instance. You need to instance, but instance is pretty fast in redshift. Don't worry about that, it's pretty fast. So the particles are gonna collide and they're gonna die. All right, so let's add a pop collision event, collision behavior. So also we needed to give more life, right? Let's put it up to 2.5. It's good for that. So then we are going to have more particles colliding in the ground. You can see we have a bunch of particles in the ground, but now here in the collision behavior, we're going to say whenever they collide, we're going to just die. So now we're going to just die, but they're not dying. Computer, they should die. They are not. Let me see what's happening here. Pop collision detect. Let's see. It should be colliding. They should be dying. I mean, let's use this one. Use a dop object, and the dop object is the ground plane. Just need to put the name. I'll use that. And let's see if they are doing what they should. Behavior. Let's make them red. They were not turning red. Are they? I don't see them being red. Why are they not red? Response. Let's just tell them to stop. Let's see. They're not working. Why the hell they're not working? Collision with the dop object. Maybe I did this wrong. Maybe. Don't know. They're not stopping. They're stubborn particles. Again, let's see what is happening here. Accumulate hits. Let's see what's happening in the geometry spreadsheet. We have particles. We have, where are you? I don't like to see this. Let's see it here. They are not dying. They're not hit total. There we go. That's what I want. Hit total. Nobody has hit anything. That's weird. Why is that not working here? It's weird. It's weirdy. So this thing is supposed to be hitting them, but let's create another object up here. Activate the collision in the solver? Should be activated. I don't know why it shouldn't be. Let's see if the solver is doing collisions. It's doing collisions. It's doing impact data. It's enable collision feedback. Everything's it's there. Let's just add another. And I've done it before like this. Let's create another ground plane here. Yeah, it only detects a collision, but they should be turning red once they collide here. Should be turning red, or maybe the color here it's just messing the visualization. Let me remove the color here temporarily, so they are all white. They're not turning red. They should turn red, right? Right. Move to hit. That's weird. Alright, so let's make another object like they're saying in the, let's just do whatever they're saying. Collision detect. Put it in a group. Top object. With this guy. Collide with that guy. Yay! Put it in a group. Collide group. Preserve the group. Yes. They are not turning red. Collision behavior. Now, should they turn green? I mean red? There's not even there. The freaking group, it's not even there. Nope, it's not there. Alright, now we're gonna just use another object. So let's create a grid here, and it's gonna collide with this grid. All right, let's call this floor. Let's go inside here and remove these guys. Go away, I don't like you. Collision detect with a sub object. Yeah, let's select the floor. Bam, and now they turn red, like they should be turning red. Right? That was what we're trying to do, but somehow it's not working with the particles with the ground plane here. They are turning red. I did nothing to them. They are turning red. I can already make them die here. They are they dying? I guess. Response none, but they turn red. So you can see there's a few red ones there. If I turn this to die, they don't die. They're dying, but it's weird because some of them collide and then don't die. Weird. Alright. Okay, do we have two ground planes? Let's see. Let's see if it works without doing that. So they're not colliding at all. Alright. So let's not make them bounce. We'll just make them, just gonna make them die. Collision behavior. I want them to die. Let's see if it works here. Nah, they bounce. They're stupid particles. Let's see if I make them collide. And whatever particles you are getting in my, let's just not do this collision for now because they're bouncing around and we have two things going on, right? Alright, so now they're freaking dying how it is, as they should be. Stupid particles. Let's put this to die. That should be working. Alright, that it's working. Alright. Okay, so they're dying, but now we're gonna group the ones that are dying. Okay, let's see. Alright, yeah, sometimes some notes are weird sometimes in Houdini, and you just have to try to figure it out. I don't know everything. I don't know everything, that's for sure. I learn as much as you guys here, so these guys are just dying, alright? And we have them in a freaking group, I think. But nah. I'm just gonna create a group. Pop group, and I'm gonna say I'm gonna tell this group, enable it, and then say group. No, I need a stream, not a group, right? Yeah, the group it's kind of the old way. I'm gonna need a stream. And I'm gonna say the particle is dead, put it in this group. Okay, it's gonna be in this stream. And that's just the only thing that's gonna happen. So, and streams are weird stuff. So this is what's gonna happen. This is the first stream of stuff. And when they collide, they die, and they get put into this stream. But we need to put a merge, and then we plug this too. So now we can see our particles, and this stream is doing something, but they're not dying. Oh my god. Go here. Oh, I need to, sorry. Let me unplug this guy, put it here. Both should be coming from this because we're detecting the behavior here. So it should die. Alright, so they're dying, but we needed a merge here because we're gonna do something else with this stream. We're gonna do something different, but this is the main thing we had, right? Just split something off of this. We're gonna do some behavior, and we're gonna put a pop replicate stuff, pop replicate, and this pop replicate's just gonna use this stream that we just created, which is this one. Just gets the name from here. So if you want to call this dead, and I'll just rewind and play pop replicate, and it's gonna see the stream is the one that it's dead, right? And now should be replicating. You can see there's particles falling here because they are actually replicating from the previous particles that died. Wow, that's weird because not everyone is doing it. See, these particles should be dying. This stuff is weird. A move to hit maybe. Yeah, why are they in I think the probabilistic thing is, nope. We can actually, let's add a color, pop color to these ones. Let's make these ones blue. So weird because this should just be working. Let me see what I did in my other example. Whatever it's dead, yeah, it's in the group. From the pop color, I think the error is here in the pop collision. They're not actually being detected as as being as collided, which is weird. Yeah, we could put an expression there, but it's not. It shouldn't be necessary. This is just totally wrong. These are not doing the right thing. Maybe don't make any response to them. So it's not working. I don't know why it's not working. It just takes like a million frames for them to start emitting stuff. Really weird deal. It's using the brain. Don't use deforming geometry. It's not deforming. See, it's just like, yeah, the particle is dead like 3 seconds ago. Now let's. You see, this particle should already be emitting stuff, and they are not. Righty. Let's say our particle. Let's see if it works. Just so see if it works. It's emitting from every particle there. So something's wrong with this stupid group. Because if particle is dead, this thing is not making it dead correctly, I guess. Color the hits and response die. It's not making them. Well, this thing is not making them die, actually. I think that's the issue. These guys are not actually being set to dead. Yeah, they are not being set to dead here with this. Even if they're dying, they are not having the dead attribute. Dead. Let's see here in the spreadsheet. Where are they? Particles. Geometry here. There should be a dead attribute here. Dead. There's no dead particles. You can see it's not setting the dead attribute, which is weird. Let's see. Yeah, it's killing the particles, but it's not setting the dead attribute. Let's put them in a group. See if they see if this makes it better. It should be setting the dead attribute there. Let's say choose the collide group, and we are not replicating. Now what? Source group collide. Make them. Maybe we can just do this and say here group collide. This got more complex than I want it to be. Nah. This is weirdy stuffy. So let's just make a wrangle. Pop wrangle, because this guy. Let's plug this guy here. Come on, little thingy. And just say that whatever is in this group collide, I'm going to the heat attribute is in the solver. I know this is not an attribute there. Okay, let's try that before we go further. It's not working. This should be there, and this should be to dead. And nope, not working. Pop replicate to the stream dead. Not working. They they are dying. These ones are when they are actually dead from from life. So let's just say that everything that is here is gonna be dead equal to 1. So let's see if it works like that. Nope. Not even that works. It's not putting them in that group. This guy is not putting them in that group. Preserve the group. Move to hit. No, it's not putting it in the group. Let's just do it with wrangle them, because that it's just not doing what we want. So if the particle position in Y is less than 0, or yeah, less than 0, let's say, we could do this here in the dead attribute instead of here. Here. Particle Y is less than 0. That should work. That should work. There we go. That's what's supposed to be happening. But it's not, which is weird. Oh yeah, I guess that could be the issue. Let's go and see here. Let's see if we need actually to have volume. We have this working now with this expression, but let's see if we actually need that. Where can I do that? Okay, let's do it here. Let's see if I just extrude this. Poly extrude it. Let's give it some distance down out the back. Let's see if that works. Well, it's working already, because actually the particles were bouncing before, so shouldn't be a problem with that. But let's see if the volume it's what's going to give us what we want. Pop, collide, collision, detect, right? Detected with the floor, right? Use deformity geometry, no. Just make them red for now. Let's not even do this part here. Just make them red. Not even red. They're not dead. They're not red. So die. They're dying now, but they're not turning red for some reason. Alright, let's see if they have the attribute, but it's still not setting the dead attribute. You can see it's not dead ever. There's no attribute setting to 1 here, or hits. There's no attribute set at all. This might be a bug. This might be. Maybe I'm stupid. Maybe I'm stupid. The heat attribute is in the solver there. Yay, the heat attribute is there. Yay. It's there. It's there. It's there. It's there. Right. So let's just go for this thing. Let's go for the expression route, because we can't be here all day. So now actually we didn't do it with this, right? We did it with this one. So let's just go for that. What did I delete? I deleted some weird stuff. Let's just go back, plug this guy. So now whenever they are dead, just kill that guy, because this is doing nothing for us. Alright, so now that they're dead, we want to emit particles from these ones that are dead, right? That's what we're doing here. Just saying, if the particle it's below this value, let's maybe make it 0, it's okay, or 0.01 maybe for being on top of the plane. Like that, we can emit particles. Now the replicate particles, but we're not killing those particles. Let's just kill it with the collision detect. We're just gonna use this for killing the particles because it's not being actually useful, so just die, so we don't have the white particles going down. There we go. So let's the replicate uses actually a sphere. Let's not emit so much particles. We're just gonna have like 100, let's say. Not even that much. Alright, let's do that. Let's see the first particle that collides. Where are you, particle? There. It emit like 4 particles. Let's make this 200. Alright, so if we go to the shape, there's a sphere attribute here, which is what's happening is it's creating a sphere and it's emitting particles from that sphere. So that's what's happening there. I don't want this sphere to be that big. Let's just make it really small. You can see the particles there are moving. That's what I'm referring to. You can see if you picture a sphere here, that's what's controlling the spread of the particles that are going to emit from there. So just put it to 0.1, so they're kind of emitting from the particle that died, and they are below the plane here. So let's see if we can actually make them go up. Yeah, because the particle is here, this particle is going to die, and the next frame it's going to be here. But instead of actually inheriting the velocity, let's go to the attributes. Don't inherit the velocity. We are gonna actually set some velocity on this. Hold on, someone's here. Alright, so the particles, we're gonna set the radial velocity a little bit. Actually add to the velocity. Let's see what particle what. We were like in 29. We're gonna add a velocity, like in this case up. Let's put it to maybe 2. You can see now the particles are kind of bouncing. Let's put it to 3 maybe. Yeah, and they're going way below the their grid, so let's put the detect before that. Let's make it 0.1 and see. There we go. See, now the particles are here and they go up. We can give it more randomness with the let's go to here. Let's not give it variance in the Y. Yeah, a little bit of variance in the Y, maybe not that much. 0.3, and more in these directions. Let's see what happens now. And we also want to kill these particles really quickly. Let's make it last for like 2 frames. If we just put 2 divided by the FPS, that will give us the correct number for 2 frames. Let's see. Pluck, 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 pluck. Looks like not really cool, but alright. Let's see how it looks here. Pixels. So there we go. Now there's kind of like little splashes or little particles there in the floor there. pretty cool. Looks cool. Let's make the sphere. We can tweak this, the shape a little bit more. Maybe the size in Y. Let's make it smaller. And we could actually make it extend more in X and Z, and not in maybe smaller in Y. So just kind of widens the thing, but nah, not too much. Not too much. And I think actually the speed might be too much. Speed up, it's too much. We can actually add noise to this as well. There's a bunch of stuff here. Radial velocity, it's also good, but I think the speed up is too much. So let's make it smaller. And I think 2 frames is too much. 2 frames, maybe they just need to be 1 frame for the hit, and then they just die. But we can control this here. It's pretty simple. Yeah, I think that looks cool. Let's see how it looks in our render. That was harder than I wanted it to be. These things, sometimes they get weird. Let's see what we got in the render. Alright, cool. We have these splashes in the ground. They are really big, and they are actually illuminating the ground, which is pretty cool. We want that. We want them to be illuminating. Let's go here where we have the randomized size for all the particles. And you can see we have little splashes of particles when they die. They just kind of split when they die, which is pretty cool. So this could be, let's make this ones more to the did 1 click too many there. Let's make this to the reddish side and apply this shader to. Alright, now these are a little bit more red instead of blue. Let's go for a little bit more intense of red there. Totally red, but not too much. Kinda. That's good for now. I think these guys are too big. We could actually control the ones that are on the floor and make them smaller, because they are kind of big, but you can actually control the overall size. They're big overall. For this, multiply the velocity. Where are we? We have in the values here. Let's reduce it by 1 notch. And yeah, that looks pretty cool. We have particles that are splashing in the ground. We could render a few frames and maybe let's see, and see it in motion. Let's see, like from 24 to 50. Let's see if we can render those while we I respond some questions if there are any questions. 25 to 50 I said, maybe, I think. Render to end play. Alright, so I'm going to render those and let's see. Yeah, we have a freaking amount of issues for this one, but it's alright. Inclusion sample, hard hit solver, pop collision detector, that. Yeah, a bunch of issues with particles today, right? In my view, I need to check if that is actually an issue, or is it just me, or is it just that I'm stupid or whatever. I always fight it. to be real, I just always fight it. Do I have a stream about shading? Yeah, we've done materials already. There's one about materials and there's one about rendering with Mantra and with Redshift. So check those out. They're pretty cool. So yeah, you can see already there's some sparks there dying. It's gonna look pretty cool. You can actually do like with this same technique, you can do like water splashes or rain splashes. You can use the same thing for water drops and stuff like that. So yeah, you get 2 for 1 with this thingy. Now it's just a matter of tweaking this and to get the effect that you want, but the basics are there. Just maybe splitting more particles to different things, or adding different emitters to have more variance and stuff like that. What are my machine specs? Everybody asks me that. It's a workstation with 2 Intel Xeons, 64 gigs of RAM, 64, did I say that? 64 gigs of RAM, and 2 graphics cards, GTX 980 and GTX 1070, no, 970 and 1070. That's the important part. I have a wacom, I have a keyboard, I have 2 monitors, I have a mouse, and I have a dog. I don't know. Alright, so let's see this thingy. You can see the particles there sparkling in the ground. There might be a little bit big, so you might need to group those and make them maybe smaller or emit less particles from there, but that's the basics of that. Looks pretty nice. It's okay-ish for now. It gets you there. Now you can just try it for yourself and make it work for whatever you want. And interrupt that. Let's just do something else. And the other thing I want to do is Ingo. Yeah, thank you for for that comment. All right, so let's just duplicate this guy. Sometimes you want maybe even longer streak or streaks that actually bend. So let's try to do that. Let's do. Here we have these particles, right? We have these particles that are just doing that. And they are on motion paths, they are moving. So one thing that I do sometimes is just create a trail. And then this is, most of the time you use this to calculate the velocity of particles. In this case, we're gonna make this into let's change this to points again so you can see the big points. We're gonna use this for copying the particles. You can see we have 2 particles here. This is the copy of it. You can see there's one. Just makes a duplicate of that, and you can set a trail to more of them. But now you can see we're getting like curves, which is cool sometimes to get. It might not be natural for the motion blur to curve stuff, but it kind of looks cool. So we're getting a little bit of a curve somewhere like this. It's curving. See, we're getting curves there. And we could connect this, guys, not as a mesh but as a polygon, and it creates little curves there. And don't make it close, so it just creates lines there. You can see now we have little lines there, which is pretty cool. And even if you, another thing you could do is just merge this with the previous one, merge this and this. Now you have like lines with a little bit of a head there. but now they are kind of a little curvy thingies. And let's see how this looks in the render. Let's make this reframe this so we can see some curves here. Let's see, let's hide that one. Let's render this. It's actually rendering. Oh, we never stopped the render. So now you can see we have like more like lines on this object, which could be another effect you could do with particles. Sometimes particles are really long and you can actually do this like this. But you can see this one, it's really weird. Like it's just not, the velocity, it's not like conforming to the curve as well. So what I do for that is actually a trick that I already show you in the aligning the normals to the curve. Let's not merge that one. You can see if we see the normals are weird right now, right? But if we see the velocity, let's see the velocity, let's hide that with a visualizer. Let's go to marker, make it a vector and use the B. This is the velocities, and let's see the velocities. You can see the velocities are not curving or not following the curve at all. So we can use that that trick that I already showed you. There's a video for this, aligning the normals. Let's align the normals here. Just make the tangent, or we can maybe align the B here. Let's see if we can align the B, and I think we can. Cool. Alright, so we can align the, but am I inverting this? Yeah, I'm inverting the velocity there, so I don't want to invert that. So I'm using the polyframe to align the velocities. Let me just use the first H. The velocities to the curve, so they are more, instead of fanning out like this, I'm kind of just aligning them to the curve more, so they look better when they're rendered. But they are being inverted. They are going in the wrong direction. So let's just invert those with a wrangle, I guess. Velocity, it's gonna be 8 times equal 1, just to invert that. Let's see if it works. And it didn't. -1, there we go. -1 worked. Alright, so we went from, if you see this line, you can see we went from that, which is fanning out, to this, which is just controlling more the curve, the velocity along the curve. So now if we render this and comparing it to this one, which is save that. I think I moved the camera, but we're gonna be able to compare it. Actually, let me render a section, make this bigger because it's really small. And you can see this is better. It's aligning more to the curve. We can actually multiply the velocity over here at the bottom, make the velocity bigger, like 5, and they're aligning to the velocity better. You can see if I disable these nodes, this looks like it's fanning out more. See that this is the render this one. I didn't save that. Scrap that. Right, now I save that. Now you can see the velocities, how they are aligning more with the curve there, like that, which just gives it, in motion, it gives a little bit more curvy thingy. So that's how you can actually make those into lines and have even maybe actually make the points have different p scale along the little curve, and have different shapes of the sparks and all that stuff. So a lot of stuff you can do here. Whoa, that's pretty big, dude. Don't want to do that. Let's make it recalculate. I don't know what happened there. That's pretty crazy. Yeah, what happened? Whoa, what happened here? The trails up got really crazy. I might be crashing. Warning, I might be crashing. Warning, warning. I don't know what happened. It just broke. I think the simulation broke. That's pretty cool. Oh man, I don't really know what happened there. Let me reset that and reset this. I don't know what happened, but shouldn't be doing that. That is weird. Alright, well, that's the idea. I don't know why this is going crazy. Everything's failing for me today, but that's the idea. You can make them curves like here, and then render those like that. If you want to make them longer, you can just make the trails up, make your curves longer. You can have that like that, and render those. They will be really long curves, which is pretty cool sometimes to render the particles like that. It all depends on the effect that you want to do, so it's pretty cool. Alright, so I guess that's enough failing for today. Let's see if there's any questions. Let's leave this render, or make it a full render with maybe 6, 7 render current frame to end play. Let's see how it looks while we check if there's any questions. I think we're left. We fail a lot today. Isaac. Gracias, Isaac. Gracias. Glad you like the tutorials, man. Cool. So there you go. This is how it looks when you give it samples, and you can see it looks pretty cool. The streaks looks pretty nice. They'll be going really fast. And when you animate this, and you can see they are illuminating the ground as well. And they look nice. They do look nice. I think that's enough for that one. Let's see if we can render another one. I guess there's no questions, and I guess everybody left because I sucked today, really. Whatever, man. Sometimes you got it, sometimes you don't. I hope someone got something useful out of this video. Let's see, that's the other ones. I like these ones. It's pretty cool. And if you add like depth of field like I did, they will look nice like the ones I did. But they do take a long time to render, for sure. See, this is the ones I made. They're made the same way. I just added a little bit of glow in post, but that's it. That's it for me. So no questions then, eh? Thank you, Prisma. I am really glad you're liking the videos. So that's it. That's how you make particles into sparks, which are really cool. Do more sparks. When every effect that you kind of make, like a fire or smoke or stuff like that, add particles, and it will make it look better. Hey Gran, thanks man. I don't know, just it wasn't that great today, but cool. We got through it. Alright guys, so I guess that's about it for today. Thank you for being here. Excuse the mishaps there with Houdini. Sometimes it happens. Right? We all battle these things. Not because I've been using this for years means that I don't have issues like this one. So if you have issues like we were having today, don't just do it. Just investigate, ask questions, and you get through it. Sometimes happens in every application. Alright, so quick question. Go ahead, Prisma. Go ask your question before I wrap it for today. I'm gonna wrap it. If you don't ask your question, you should have just typed your question instead of saying quick question. Can I ask one question? Yeah, you already did. If they were to determine if a node is old one or new one, no. Well, maybe just reading all the documentation of Houdini since the start of Houdini. No, you just what I do is just I always read the help. That's how I know when a node is new, because I always read the what's new. So if you read the what's new, then you know what's new. So start reading the what's new. Start reading it. Like if you go, let's say, go to the geometry and modeling, you're gonna see, yeah, this thing is new. This snapping is new. This Boolean node is new. This polyfill is new. This topple bill replaces the polynode. That's how you know. Just reading about it. Yeah, I think that's what's happening. The IDs might be getting lost there. Alright guys, so that's gonna be it for today, man. Or girls, I don't know if there's girls in the chat, but alright. See you guys later. Thank you for being here. I really appreciate it, and as you can see, I really mean it when I say let's keep learning together, because we are always learning. I'm always learning. I'm glad that you guys can learn something from me, and I'll see you guys in the next one. Alright, keep it cool guys. See you next Wednesday, same time, same cool stuff. Alright, laters. As soon as I find that button, you know I always lose that button, right? I never know what that button is. Where is it? Don't see my projects. Ah! Where's that button that I need to press? Where is it? Who knows? Oh, actually there was some weird stuff in the stream today. Weird. Alright. Alright guys, see you later.